In the next example, we have an acceleration function. So acceleration, and we know that acceleration is the second derivative of position. So our acceleration is negative 32. We know s of 0 is 80, and the first derivative at 0 is 64. So we want to find our position equation. And we're going to find a particular one because we were given initial conditions. So we're starting with the second derivative is negative 32. And we're going to take the antiderivative of that, of course. So the antiderivative of the second derivative is the first derivative. So our first derivative is going to be negative 32t plus c1. And I'm going to call it c1 is because since we're dealing with the second derivative, we're going to have another constant later on. Now, I can solve for this because I also know that if you plug in 0 into the first derivative, we should get 64. So this tells me that c1 is 64. So that means the first derivative is actually negative 32t plus 64. All right, now I'm going to keep going so I can find the position function. So I'm going to take the antiderivative again. So that'll give me s of t. The antiderivative of negative 32t is negative 16t squared, and plus 64t, plus another constant. I'm going to call this one c2 because it's different than the original one. And I can figure out what that is because I know that if I plug in 0 into the position function, I am supposed to get 80, which means that c2 is 80. So now I can go back and write my position function as negative 16t squared plus 64t plus 80. So that's what we mean by finding those particular solutions, is going on a step further and making sure you know what those constants actually are. All right, for our last example for today, we have this differential equation. First, we want to verify that y equals cx cubed is a solution. So this is a two-part problem. So first, to verify, our solution, we were told, is this. We need to plug it in this to see if it works. And notice this has a first derivative in it, so I'm going to need the first derivative of this, which is going to be 3cx squared. And now that I have that, I'm going to plug into this. So we have x times the first derivative minus 3 times the original function. I want to see if that's 0. So we get 3cx cubed minus 3cx cubed. And that does work. So we have verified this is a solution. All right, then the second part. Let me switch colors so you can see the second part better. Find the particular solution determined by the initial conditions, y equals 2 and x is negative 3. So remember, this is our general solution. To find a particular solution, we want to find out what c is. So we're just going to plug in these values that they gave us. So y is 2 when x equals negative 3. So we get negative 27c, so c is negative 2/27. So our particular solution is y equals negative 2/27 x cubed.